In a previous video, I gave an overview of the template method design pattern. In this video, I'm going to implement that pattern as an example in a Java program. Quick refresher on the template method design pattern. The idea is that we want to place the structure of an algorithm in a superclass. In our case, that will be this class called vehicle. But then we're going to allow the subclasses to override specific steps. Now, the example that I have here is an indication that we're up for our regular service interval for a vehicle. And that can vary based on the vehicle. So an electric vehicle, a hybrid vehicle, a performance vehicle, a truck, a normal sedan, they're all going to have different service intervals. They're typically 30,000 miles, 60,000 miles, also on the low end, 5,000 miles, and 100,000 miles on the high end, and so on and so forth. But that could vary. And also the services that you require will vary, especially based on the engine type. So this is a perfect example where we can use the template method design pattern because we can watch for the odometer to hit a certain point, ask the vehicle subclass, is this the point where we need regular service? And oh, by the way, if so, what service do we need? And then we can tell the user. So let's jump right in. I'm starting with our existing vehicles project, and I've created a new branch called design patterns because I plan on doing a few other design patterns in this branch, including singleton. And having it in this branch, you can go to GitHub and see exactly the changes that I'm making now. Now, in previous videos, I've made our class hierarchy, including vehicle. So let's start to define that high-level algorithm. I have created a method check for required maintenance that returns a list of type string. Now, a forewarning here, if you find yourself returning strings from methods a lot of times, you're probably not doing a good job of object-oriented design because really a string is dumb. A string is just letters. What we really should have is a service object, but for simplicity, I'm just returning a list of strings where each string would be some kind of service message like change the oil, rotate the tires, overhaul the engine, spark plugs, that kind of thing. So this is where we're going to define that algorithm in our superclass. Now what I've created so far is required maintenance, which is a variable that we're going to return. Right now it's going to be empty, but we're going to see if we need to populate it. After that, I'm invoking a method that does not yet exist called getServiceInterval. We'll figure that one out in just a moment, but it's returning an int. And that int says that when the odometer reaches this point, we need to check for service. Okay, in that case, we need to know when we've passed that point. So in our go method, I'm going to make a new attribute that records the odometer reading before we move the vehicle, and then the odometer reading after we move the vehicle will be updated automatically on this line number 45 where we're saying set odometer to the previous odometer reading plus the miles driven. Note I'm declaring previous odometer is an attribute up here, and you know, I made it protected. I really could make this private, because there'd be no reason for a subclass to override this because the whole algorithm is in the superclass. So that's kind of a design call, but nonetheless. Now I'm setting previous odometer here in the go method. And remember, go is what we invoke when we want to move the vehicle a certain distance. So we store the current value of odometer and previous odometer, and then we increase the odometer by miles driven, and that gives us a range of miles where this was driven. Now we can go back and continue to implement our algorithm. So note our if test here. We're saying if the service interval, which we're going to get from the subclass, is greater than the previous odometer and less than the current odometer, and you know what, let's go ahead and make that less than or equal to and greater than or equal to, then we need to prompt for service. So note that I'm invoking a method I've not yet created called getRecommendations, and I'm saving that to required maintenance. But only if this if test evaluates to true, and of course now I also realize I have the equals on the wrong side. Okay, fixed easy, there we go. So only if we have driven beyond our maintenance interval in miles, then we will ask for required maintenance and return required maintenance. Otherwise, we'll simply return an empty array list of strings, which means no maintenance required. Now, here's the trick. And here's where we need to think about the template method design pattern. Remember what class I'm doing this in. I'm doing this in the class called vehicle. Remember that vehicle is the superclass. And we also know that the subclasses should be able to define their own service interval and their own required maintenance at that service interval. So, how can a superclass call into a subclass? Because a superclass doesn't have knowledge of its subclasses. As a matter of fact, it's better that it does not. Because that means we can define a superclass today, and we can define the subclasses for it in the future. And that's great. That's what makes programs customizable and extendable, is this knowledge that we can do something in the future to extend a superclass. So given that, how can a superclass reach into a subclass? Well, the answer is an abstract method. And an abstract method is somewhat like an interface, except it's in a class. What I mean is, interfaces just have method signatures, right? And we know polymorphism, we can use interfaces as a variable type, but not an object type. But what's the use of having an interface if it just has method signatures and not implementations? Well, if a class implements that interface, it has to provide an implementation for each of those methods. Let's combine that concept with the concept of a superclass. What if we had a superclass and we wanted to define some method signatures, but leave that implementation up to the subclass? That's where we have an abstract method. So we simply put the word abstract in the method signature, but we also have to make the class abstract. And what that means is we cannot create an object from that class because it has method signatures that have not been defined. So an abstract class, by definition, we cannot instantiate an object out of it. However, we can instantiate an object out of its subclasses because the subclass provides a definition for that abstract method. So let's go ahead and make these methods, and because I've given some intelligence here, there's a good chance that our IDE can help us out. So I Alt-Enter and say create method get service interval, and you see it's figured out, yeah, it needs to return an int. Now, the trick is we need to make this abstract, which means I need to put the keyword abstract in it. And the other trick is if it's an abstract method, it can't have a method body. So I have to take the curlies out and the body definition out and terminate it with a semicolon. Let's do the same thing for get recommendations. And by the way, you notice there, private abstract int get service interval. It's just a method signature, right? There's nothing actually going on in it. So get recommendations, we do a similar thing. It has successfully figured out the return type. We simply add the keyword abstract and then take out the method body, and there we go. Now we're still getting a red line on abstract, and the reason private's not good, let's go ahead and change that protected, because this should be overridden by the subclass, and if it's private, it cannot be overridden by the subclass. But if it's protected by definition, the subclass can inherit this method and also can override it. In this case, it actually can't inherit the method because there's no method body, so it has to override it. But nonetheless, this method signature is available to our subclass. Still getting a red line, and it says abstract method in non-abstract class. Well, this is definitely fixable because remember what I said, if we have just a method signature, you can't create an object out of it. You have to have a method definition, implementation. So abstract methods can only live in abstract classes where that abstract keyword says, don't instantiate me, instantiate one of my children. And that's easy to set up. We simply say abstract. Up here in the class definition line, and in this class now, all of our red lines are gone. But we're going to find out that we've just introduced a few more red lines. And why is that? Because we have several subclasses of vehicle, and they now are breaking the contract because they're not providing a definition for these methods. It doesn't appear so right away, but as soon as I click into Sonic, look at that, we get a red line. But the good news is the IDE can help us out. I hold Alt, I press Enter, implement methods. And let's say for a Sonic, let's call the service interval 25,000 miles. And for the recommendations, we'll say oil change, spark plugs, tire rotation. And now you see I've given this a method body for both of these abstract methods. We have our service interval of 25,000 miles, and we have our recommendations of oil change, tire rotation, spark plugs. So I need to do this for each class I have that's extending vehicle. That'll take a little bit of time, so I'm simply going to do copy paste, And notice again, Mustang extends vehicle, but we have a red line because we're not implementing all of the abstract methods. So I paste in these methods, red line goes away. I'm going to change the service interval to 20,000. We'll say Mustang, a sporty car, probably needs a little more frequent service. Oil change, tire rotation, spark plugs. Let's take out spark plugs on that. 20,000 miles is a bit early for spark plugs. Maybe we'd have another service interval where we handle that. Nonetheless, we notice that the Mustang now has a different service interval than the Sonic, which is not a surprise. They're two different cars. However, all Sonics have the same service interval. All Sonics with the same trim level have the same service interval. All Mustangs with the same trim level have the same service interval. I would think so, at least. I would hope so. So that's why I feel safe hard-coding some of this information in here. Now let's go to the Prius, which is going to be an interesting one. We'll notice we have a red line. Prius is an interesting one because we're not always using the gasoline engine. So I'm going to take off oil change, and I'm going to take off spark plugs because they might not get as much wear. And I'm also going to adjust the interval to 30,000. But what I might add here is check the battery. So the battery that holds the electricity, we want to check the battery health and make sure that it's still holding a charge. And that, of course, would be something that is unique to Prius. So now I save and just double check, go back to vehicle. Now, here's the cool part, and here's where the template method design pattern I think is awesome. Remember, we're back in the superclass vehicle, and we're in this method called check for required maintenance. And we're doing our math here, but notice that from this method, check for required maintenance, which does indeed have behavior in the superclass. In other words, it's implemented in the superclass. It has a series of steps in the superclass. It can call these abstract methods. Even though only the signature is defined in the superclass, it uses the magic of dynamic binding to reach down into the subclass and say, hey, what's your service interval and what's your suggested maintenance? Now, we simply need to invoke this method, check for required maintenance, when we're running the car, which is going to be in our driver program. I'm going to get rid of an earlier example that I had here. Now you notice that it's returning the check for required maintenance into a list of strings. We'll simply call that required maintenance. Now remember the trick here. If there's nothing required at this interval, it's going to return an empty array list. If there is something required, it's going to return a populated array list. So at this point, the easiest way to deal with that is a simple loop of some type, either a stream or a traditional for each loop. I'll probably use a traditional for each loop because if that collection is empty, the loop body will never execute. So by default, we get that behavior of, okay, nothing to do, provided that we didn't get any messages back. But if we did get a message back, then we want to display that to the user. Now I'm nearly ready to run this, but I did notice an interesting red line. In a previous video, I did an example of a factory method design pattern where we declare a vehicle variable and then we instantiate it to the correct subclass object type. But by default, I constructed a vehicle. Note, I'm not allowed to do that anymore. You see, we get a red line here, and the red line is because vehicle is abstract. And remember, we cannot create an object out of an abstract class. So I simply have to declare this as null, which is really dirty because that could throw a null pointer exception. So this is something we might want to come back and refactor, or at least check the calls to this method to make sure that we won't get a null pointer. But that's just a bit of an aside. At this point, let's go ahead and run and see what we get. Go ahead and choose our Sonic, and we'll say 25 miles per gallon, 10 gallons of gas. Odometer here, we want to be careful because we remember the service interval on this was 25,000, so we want to make it something close to 25,000. Say 24,950, 50 miles shy. And then do you want to create another vehicle? No. And how far do you want to go? We'll say 100, which should take the odometer over that important point of 25,000 miles. And take a look what we get. We get suggested maintenance oil change. We get suggested maintenance tire rotation. Forgive me, these are popping up on my other screen, which is why I'm dragging them over. And suggested maintenance spark plugs. And then after that, do you want to take another trip? We'll go ahead and say no here. So you see that it is indeed displaying some output there, knowing that we've passed this maintenance interval. I could run again, and this time try it with something that is outside of that maintenance window. I'll keep everything the same except the odometer. I'll make it maybe just beyond that maintenance interval. And then we'll say, okay, how far do you want to go? We'll say 100 miles. This time around, we should not see the maintenance interval message pop up. And sure enough, we do not see it. It simply asks if we want to take another trip. And for that, I'll say no. Now, let's take this through the debugger. But I'm going to snap a breakpoint in vehicle, in our algorithm that we've defined in vehicle, so that we can watch carefully and see what happens when we invoke get service interval, so we'll set the breakpoint there, and also get recommendations. Again, same values as we've seen before. Odometer, once again, I'll do it right before that service interval. And now we get an option, do you want to enter another vehicle? We'll say no. And now how far do you want to go? We'll say 100. So take a look very carefully up towards the top here. You notice that we're currently in the vehicle class and we're invoking get service interval. We know get service interval is a method that we have defined down here towards the bottom, but only the method signature, not the implementation. So when I go to debug and I choose step into, watch what happens to the tab up here. Aha! I've now walked into the Sonic class. So you see that from the superclass, we're able to put a hook into our subclass. So we return that service interval. We can confirm that we have just passed the service interval in driving. So we require service. So now I'm going to invoke get recommendations. Once again, I'm in the superclass vehicle, and get recommendations is a method signature defined in the superclass, but the implementation is not defined because, again, it's abstract. So when I choose to step in here, watch very carefully to see where we go. No surprise, we're back in Sonic, and we are adding to this list the requested or required maintenance specifically for Sonic. We don't see the maintenance for something like check the battery level or anything else like that that's specific to the Prius. We see that the oil change comes up, we see tire rotation comes up, and spark plugs come up. So those have been returned to us, and then we have the option, do you want to take another trip? And for that, I'll choose no. So in this video, we've seen the template method design pattern implemented in a Java program. Template method and abstract methods are very powerful and something incredible that we can use when we put them together. So as always, I hope this video was helpful, and I look forward to reading your comments. Thank you.